So I have told you that the combined effect of all the vectors acting on a object simultaneously is known as the addition of vectors. Okay, and actually the addition means the same thing, a combined effect. If you add two scalar quantities, for example, if you add 4 and 3, we actually take the combined effect of 4 and 3 or collection of 4 and 3. 4 unit and 2 unit, after that we got 6 unit. This is the combined effect of 4 and 2. And now the important thing in that is we got only one quantity after adding. Yes or not? Means if you add 4 and 2, two quantities are added and we got 6, one quantity. Similarly, if we add two vectors or more than 2 or 3 vectors, more than many vectors, then we got only one vector, because you think in a real perspective. If 5 players kick a ball, in how many direction it will go? Only single direction, yes or not? Or in how many ways, or how much forces or direction velocity it will move? Your answer is single value, yes or not? It cannot take at the same time two different values. If it happens, then at the same time ball is slow, at the same time ball is faster, at the same time ball has greater effect, and at the same time ball have lower impact. This cannot be possible in real sense, yes or not? Ball will move with same impact, ball will move in the same direction, only one single direction, ball will have same speed at one moment. So we got a single physical quantity after combining all the vectors or all the physical quantities. Have you got my point? This is the important thing, that if you add all these things, we got on a single. So we can say that the combined effect is a single vector that gives the same result, which can be given by all the forces acting together on that point, on that object. Have you got my point? So here I have discussed that what do you mean? What do you mean by to add? I have discussed. To add means combine. Yes or not? To add means combine. To add means the net effect. To add means the single result. To add means conclusion. Means if we combine two or more than two vectors, it means we add two or more than two vectors. It means we find a vector, a single vector, which give the same effect and same effect as in the case of they act together. That means if 5 players kick the ball in the different direction, after the kicking, ball will boom in the single direction. Or after the kicking, ball will have a single impact or force or speed. Where instead of the player before the kicking, various players can act by various forces and in various directions. But after kick, the ball will move in the single direction with single impact. This is the resultant, or you can say resultant. Resultant. This word is important. Resultant or net. Have you got my point? It is the meaning of addition of two vectors, or you can say in addition of anything. and a scalar also. But here we are studying vectors, so I only give the term vectors. So the adding of two vectors means combining the two vectors, or we want to find the combined effect of various vectors or many vectors, or we have to know about, we want to know about net effect of many vectors, or single result or conclusion about the many vectors, or the effect and resultant of the many of several vectors. Now I have given you example. Now I give you some another example. How can you add this kind of problem? So you have known the simple cases. We can add it by plus and minus and then can solve it. But in this case, answer must be, I give you answer must be in this direction, and the value is 5 Newton. But here, if we take this direction as positive and this direction as negative, what you find? Plus 3 plus minus 4. What you got? Minus 1 Newton. This is wrong. Or also you can see here, this is north-southward, or this is eastward. This is perpendicular direction, not in a single line. It is in two lines. In the previous cases I have shown the examples. We take the single line, either this or this, or either this or this, or either this or this. It means forces are acting on a line. For example, if I take this is an object, a body acting on it by 3 Newton, and another is 4 Newton, another is 6 Newton. What is the combined factor of these three vectors? It becomes, if you take this direction as positive, so it becomes plus 6 plus minus 4 plus minus 3. What will got? Minus 1, which is correct answer. Here you can see that the forces acting on it in the same direction. Either this, either this, either this, either this. Means same line, or this line. Any kind of line, but same line, along the same line. Either rightward or leftward. Have you got my point? But here the case is different. One force is in this line, means in this line, another force in this line. So there are two kinds of lines. So how we add? If you add by the previous method, we got the wrong answer, because actual answer is this. So for this, processes, or how can we describe it by mathematics? So we need something. What we need? Which things we need to add two vectors? First of all, we must have knowledge about geometry, simple geometry, and the some basic trigonometry. I will deal about the trigonometry now, but here, and the third point is patience and hope. So if we tackle any new problem, we must have patience and hope. If you agitated it, if you divert it because it is difficult, then you become you cannot got a knowledge. So, and of course you must have some brain power. Otherwise, how can you tackle mathematics and science or anything? Okay. Now before this, before we going to trigonometry, I am giving you some examples and the information about the units of some physical quantities which is necessary. Now, here are some physical quantities and SI units are given here, and the speed and velocity has same SI unit, meter per second, because it is measured by the same unit. The speed is also measured by meter per second and velocity is also measured by meter per second. But this is scalar quantity, but and this is vector quantities. We will deal about it ahead, but here we only deal about the units. So here I have given you some problems you must have to solve on your notebook. So by pausing the video, you can write the questions and the information I have given you here. So unit never be changed if the types of velocity or types of term is changed. If it is a uniform velocity, if it is a is non-uniform velocity, no matter, its unit is same because it is measured by the same parameter, meter per second. So now here acceleration or deceleration is measured by meter per second, its unit SI unit is meter per second. You can change by this. You can solve these questions on your notebook. Now momentum impulse is measured, or its unit is kg meter per second. Here is the question, you can solve it. If you have any doubt about the problem or you want to match the answer, you can ask me question on my YouTube channel, or you can comment on it, or you can mail me. I can give you the answer. Now this is next force, all kinds of force, magnetic, gravitational, muscular, molecular also, and this is the SI unit of force is kg meter per second square, which is also called Newton. So you can solve it. You can convert another unit, 1 kg meter per second square is what gram centimeter per hour square, and so on. Here in CGS system, gram centimeter per second square is also known as dyne. So you can convert 1 Newton into dyne. You can solve it on your copy. Power, here power is measured by watt, kg meter square per second cube. Watt is also called joule per second. Now you have a question, 1 watt equal to what? Gram centimeter per second square. Now the another case is in CGS system, it is also denoted as arc per second, and another practical units are horsepower. 1 horsepower equal to 746 watt. It means a machine can do 746 watt. If a machine can do 746 watt, it means then the adult horse also can do the same work. So 1 horsepower is 746. In ancient or British, in Britain, it is all power is denoted by the horsepower, because everything is taken by the horse in ancient time or previous time. So now energy or work. Here energy unit of SI unit of energy kg meter square per second square is also called joule. You can convert it, 1 joule equal to gram watt gram centimeter square per second square. In CGS system it is known as erg. So you can convert 1 joule equal to watt erg. And in practical another practical units are calorie. 1 calorie means 4.2 joule approximately. This unit calorie is used in the nutritious to find nutritious energy. You know about it. Okay. Now another physical quantity is pressure. Pressure is measured by kg per meter per second square, or you can write it kg per meter into second square, or this is also called Pascal. Or Pascal is also, you can write it Newton into meter. Other units are 1 atm or 1 atmospheric pressure, which is equal to 1.013 into 10 to the power 5 Pascal. Or you have another unit, 1 atm equal to pressure of 760 mm of Hg column. Or you have another unit torr, which is 1 atm equal to 760 torr, or you can say 1 mm Hg of pressure is known as torr. So here is a problem. You can convert it in your notebook. Now the another physical quantity may have volume. So its unit, you know about it. Its SI unit is meter cube. But in chemistry sometimes its unit is different. So in chemistry, unit of volume is liter, or generally milliliter. So how we convert meter cube into liter? That is very simple. I give you conversion. 1 decimeter cube must be 1 liter. What do you mean by that? It means if I take a cubical box whose dimensions are, means length 1 decimeter, breadth 1 decimeter, height also 1 decimeter, means its volume becomes, you know about the formula, length into breadth into height. So it becomes 1 into 1 into 1 decimeter cube. It means 1 dm cube. So what is how 1 liter is defined? You can say, if you pour the liquid in this box and you fill it completely, then the space covered by this substance is known as 1 liter. Have you got my point? Means if you have a cubical box which have dimension 1 dm cross 1 dm cross 1 dm, if you pour some water in it or completely, then the space covered by the water is equal to 1 liter. So we can say that 1 dm cube is equal to 1 liter. You can convert it 1 centimeter cube, or you can also convert it 1 meter cube with respect to liter. I have given you question. Try it out by yourself, that 1 liter equal to how much centimeter cube, or 1 liter equal to how much meter cube. Do it yourself. Now the next next physical quantity is area. So I am giving here area. So you know what it, the unit SI unit of area is meter square. There are another centimeter square. You see here, area must have unit square on the meter square, and volume must have unit meter cube, because volume is the perpendicular multiplication of three quantities, and area is the perpendicular multiplication of two quantities. That's why if we got the length as we measure the length in meter, then meter must be multiplied 3 times in volume, and meter must be multiplied in 2 times in area. That's why in area it is a square meter, and in volume it is a cubic meter. So you can convert it. I give you some problem. You can convert it by yourself.